All right, the third video that we're going to go over talking about some prerequisites for pre-calc, and we're going to talk about the slope of a line, and we're going to talk about writing equations of lines in slope-intercept form and also point-slope form. And then we want to be able to write equations for parallel and perpendicular lines. So you definitely should know how to do this coming into this classroom. You should know what slope is, which is the rise over run, also known as delta y over delta x. And when you see this delta, that means that you're subtracting two values. It's used a lot of times in science classes and then also advanced math classes from here on out. So the change in y over the change in x, there's our slope formula. So we really should know how to find slope at this point. Point slope form is one that's not used so much, but really all it does is it comes exact right from the slope formula. And what it's doing here is it takes and gets rid of the fraction, so it multiplies both sides of the equation here by x2 minus x1. And by doing that, I'm going to rewrite it slightly. Here, this is going to cancel. I've got now, I'll write this out as x2 minus x1 times m is equal to y2 minus y1. And really right there, that is our point slope form. Now it gets written out in a slightly different way when you see it written in textbooks, and how they'll have it written out is y minus y1 is equal to m times x minus x1. And what it has here is your equation. You've got your slope, which is what m is, and your x and your y, you have your independent and dependent variable, and your point that we are going to be substituting goes in for y1 and for x1. So to show you, show you an example here is, let's say we have an equation that has a slope of, let's go 4, and it goes through the point of 2, 7. So if I'm going to go through this here, I'm going to go ahead and plug in the 2 in for y1, 7 in for x1, and 4 is going to go in for our slope. So my equation of this line is going to be y minus 7 is equal to 4 times the quantity of x minus 2. And there's your equation of your line in point slope form. Now we do not use this one a whole lot. Most likely we use slope intercept form. And slope intercept form, comes from point slope form. And really all it does is it simplifies it for us, solving the equation for x. So here I am just using a random example. Notice I have a slope of 2 and then I have my 2 points in there. But if I wanted to write this in slope intercept form, I would eliminate these parentheses using the distributive property. So y minus 4 is equal to 2x plus 6. And then I can add 4 to both sides and get y is equal to 2x plus 10. And our slope intercept form is y is equal to mx plus b, where m is your slope and b, remember, that's your y-intercept. So these are two formulas that we'll be using, not so much the point slope, but definitely the slope-intercept form that we'll be working with. Let's say you wanted to write an equation of a line with a slope of 7 and a y-intercept of 5. You could write this out in two different equations. Probably the easiest one that we will do is just y is equal to 7x plus 5. There's your slope-intercept form. If you wanted to do point-slope form, since your y-intercept has the point of 0, 5, we could go ahead and plug in y minus 5 is equal to, is equal to our slope, which is 7, times the quantity of x minus 0. And there's your point-slope form. So slope-intercept, point-slope, there they are. Let's say you wanted to write an equation of a line that passes through the point of -5, 7 and has a slope of 8. What a lot of times people like to do is they like to say, okay, this is y is equal to 8x plus 7. But 7 is not your y-intercept. It goes through the point of negative 5, 7. That is nowhere close to your y-axis. It's a coordinate. They do not tell you what your y-intercept is, so we need to find that. Again, you can choose if you want to do slope-intercept form or point-slope. If we do slope-intercept, we need to find our y-intercept. So I'm going to plug in 7 and negative 5 for our x and y. So 7 is equal to 8 times mx, so negative 5, plus b. So I have y equals mx plus b. And so now I've got 7 is equal to negative 40 plus b. Add 40 to both sides. And now 47 is equal to b. So now I have my y-intercept and I know what my slope is. So y is equal to 8x plus 47. So there's our slope-intercept form. In a problem like this, writing it out in point-slope form, really easy. I've got y minus 7 is equal to 8 times the quantity of x plus 5, since it's usually x minus x1, since it's minus and negative, we're going to add that. So there's our point slope. If you wanted to write an equation of a line that passes through 2 points, well, with both the equations, point slope or slope intercept, you need to know what the slope is. So we need to go ahead, and the first thing we definitely need to do is figure out what the slope is. So we're going to find out the change delta y over delta x. So the change in y over the change in x. So negative 1 minus a negative 8. Divide that by 4. Subtract a negative 3. Negative 1 minus a negative 8 is actually adding 8. So that's going to give us 7. And 4 plus 3, so then that gives us 7. So we have a slope of 1. Now, putting this in slope-intercept form, we need to find our y-intercept, which is neither of these 2 points. So by just picking one of the points and using our slope, we can find that y-intercept right away. So y equals mx plus b, so negative 8 is equal to 1 times negative 3 plus b. So negative 8 equals negative 3 plus b. Add 3 to both sides. Negative 5 is equal to b. So there's my y-intercept. With a slope of positive 1, y equals 1x minus 5, or y equals x minus 5. There's our slope-intercept. Point slope, you have 2 options because we have 2 different equations. We can do y plus 8 is equal to 1 times x plus 3. That's one option. Or you can use the other point and do y plus 1 is equal to 1 times the quantity of x minus 4. And all 3 of these equations are the equation of a line that's going to go through those 2 points. Now, talking about parallel and perpendicular lines. Remember that 2 parallel lines are parallel if and only if they never intersect. Therefore, the slope of those 2 lines must always be the same. So if one has a slope of 2/3, the other one must have a slope of 2/3. Looks like it's not equal to. So they must have the same slope if they're going to be parallel. If 2 lines are perpendicular, then they are going to intersect and create a 90-degree angle. Therefore, the slopes of the lines, remember, are opposite reciprocals to each other. So if I have a slope here of positive 2/3, the perpendicular slope is the opposite, making it negative. Reciprocal is going to be 3/2. And those would be perpendicular to each other. Now I have an assignment for you to do. My last example that I have is I want you to try and figure this one out and come with it to class tomorrow. And what I want you to do is I want you to come up with 2 equations in slope-intercept form. So you're going to come up with 2 equations in slope-intercept form that go through this point, and one of them is going to be parallel to the line of y equals 2x plus 7. The other is going to be perpendicular to y equals 2x plus 7. Now this is review. You've talked about this in Algebra 1. You did this in geometry. You did this in Algebra 2. So I am holding you accountable that you will be able to do this. Once again, with you to class, you are going to find two equations going through the point of 8, 4. One of them is going to be parallel to the line of y equals 2x plus 7. The other is going to be perpendicular to y equals 2x plus 7. Ask each other questions, help each other out. If you do not know how to do this problem, try and figure that out before you come into class. Any questions that you might have, make sure you write them down so that you can ask them tomorrow.